Hi, I'm Grace Sato from Team Save Sato. I'm a rising junior from Oregon, and for my project, I designed and tested a filter that can remove toluene, ethylbenzene, p-xylene, and m-xylene from water. These chemicals are extremely toxic to humans, and they are leaked into water through crude oil spills. Oil spills are a big issue, and as long as we rely on petroleum products and fossil fuels, they will continue to contaminate water. In Nigeria alone, thousands of oil spills, coupled with inadequate water filtration systems and unreliable emergency drinking water supplies, has resulted in hundreds of thousands of people being continuously exposed to unsafe water. The most harmful chemicals in crude oil include BTEX, benzene, toluene, ethylbenzene, and xylenes. They can cause brain damage, infertility, liver and kidney failure, and an increased risk for cancer. My goal was to create a more accessible filter that captures these chemicals so that people do not have to suffer from them. I used a gravity filter design because it is both simple and easy to assemble. The filter is made out of all common materials that can be recycled from trash, and vegetable oil is both cheap and abundant. Since vegetable oil and the BTEX chemicals are both nonpolar, but water is polar, I believed that the BTEX would prefer to be in the oil. I made a contaminated water sample using crude oil and distilled water. I then poured this mixture through my filter. It was broken up into smaller droplets by the mesh in the inner chamber and then passed through the vegetable oil. The water leaves through a hole in the bottom of the inner chamber and passes through the outer chamber. The water in the outer chamber keeps the oil in the inner chamber, preventing it from leaving and recontaminating the water. I used a gas chromatograph mass spectrometer to analyze my results. I found that 96.7% of the m-xylene was removed in the filter, and toluene, ethylbenzene, and p-xylene were removed in the filter down to levels that the GCMS could not detect. One of the big problems with other filters that remove BTEX is that they are much more complicated and they cost a lot more. My first prototype cost me only 40 cents to assemble, while household brands can cost at least $30 and up to over $300. Commercial brands require special parts, and they are not easily assembled by the user. The safe filter is both simple and easy to make. Even though the safe filter is cheaper, it still removes similar amounts of BTEX. Commercial filters filter out 98 to 99% of BTEX, which is only 1 to 2% more than the safe filter. The safe filter can provide a temporary solution for people who lose water treatment for a short amount of time due to a pipeline rupture, or provide a long-term solution for people who face chronic BTEX water contamination. Everyone deserves equitable access to safe drinking water, and I want to do my small part in helping us achieve SDG 6. Thank you so much for listening.